Hey everybody. All right, I want to show you a couple features in Onshape that we need to sort of have a good idea about going forward. One of the features I want to talk about today is the sweep feature. What sweep does is it will take a shape that you've made, and if you have a line going in a perpendicular plane to that one, it will take that shape and basically extrude it along that line. It'll follow the line, so you can make shapes that have like the same cross section, but maybe they're turning around at different locations. So a good example of something you can draw is like a paperclip. So I'm just going to do a sketch. I'm going to use some straight line segments. Let me see. Maybe I'm not going to make it to scale or anything. I'm just going to make vertical line segment here. I'm going to turn that into an arc that starts here and comes around to be about the same height. Let's see if I can get it to be the same height. Yep, there we go. This will be the inner loop. I'm going to, from there, make another vertical line. Goes a little bit down. Make another tangent arc. Goes out a little bit farther. There we go. And another line segment. It's kind of an upside down looking. To me, this is upside down looking. Let me make this a little smaller at the top and a little closer in here as well. Does it have one more loop? See, paper clips go loop, loop. Ah, there's one more loop. That's why it doesn't look right yet. So let me drag, hold on, let me drag the endpoint of this up so it's horizontal to these guys. And I'll do one more across there. And one more piece that comes on down. There we go. And we have, let's see, I move this down to the same level as that. Oops. Undo. That's not what I wanted to do. I didn't want to snap it too. I just wanted to make it the same level. I can't do it because they're too close. Okay. Make it wider. Make it, oh no, it's going to always try to snap to it. Okay. I'll snap to the origin then. That's fine. I want these centers to be centered on each other. Okay, cool. It's going to look really weird. It doesn't look very normal to me as of right now. Okay. I'm going to go ahead and save this sketch. So I kind of made a weird looking outline of a paperclip perhaps. And the endpoint here, the endpoints land on the plane that's my top plane. So I'm going to spin my top plane around. And I'm going to look at that straight on. And the end of my sketch, I stuck to the origin. So I'm going to put a circle, sketch a new sketch at the origin centered, and make it a little smaller than what it looks like I could go out to any of my other lines. I'm going to keep it small enough that it's less than halfway across. And green check it. All right. So I've got lines that are on one plane and a shape of some sort of closed form that's on another plane at the location of the endpoint of that line. The sweep feature kind of looks like a tube or a snake going around here. If I click on sweep, it wants me to take a face and sketch region to sweep. So I'm going to pick my circle here by clicking inside of it. Sweep path. Well, that is that's a sketch right here. And I can pick all the little parts of it, and it will sweep that circular cross-section around, giving you something that resembles a paperclip, although I don't think I did a very good job at making it. If I go back and edit this sketch, this original sketch here, if I make this part wider and this part come in a little ways, this part, no, you know, why is it all, is it because I snapped this to, probably, here we go. Let's see if we can make this a bit of a more paperclippy shape. Let's see what that does to it. Oh, that looks a little more like a paperclip. Not bad, not bad, not bad at all. So that's what a sweep will do. They also want to talk to you all about making something that tapers in. And I know we have done a taper before, or a when you do draft angle or taper. But if you're not extruding something, like you can do it with a rotator, revolve as well, if you have a round surface. You can also use a chamfer. But I want to teach you how to do a revolve to make a tapered endpoint on this thing. So I'm going to make another sketch on the same front plane here. I'm going to use this one because it's all centered at the origin. I'm going to make a little sort of a trapezoid shape here, go down a little ways, come out, but not as far as that is, and then go up to that point right there. I'm going to have to probably go in and actually measure those two distances. Yeah. If I go back to sketch 1, no, not sketch 1, sketch 2, what's the radius of this circle? Let's get a dimension on there. 0.08. You know what? 0.08 sounds grand. Let's use that. And then on sketch 3, I can tell it that I want this to be 0.04 exactly. And that should match up because 0.08 was the diameter. 0.04 will be halfway across the radius. All right. I grab this guy and I do a revolve, which is a thing that looks like a donut that's had a bite taken out of it. And I revolve 360 degrees around, an axis. Do I have an axis? Well, I'm going to use the axis that I've already drawn, that line right there down the center. And it's made a taper. So the end of that tapers. It wouldn't be as pointy and catch on your paper as easily when you slide that together. If I had a good dimension as to where the center of this end point here is, then I could conceivably do the same exact thing on this end. Alrighty, that is using sweep and using a revolve to make a tapered endpoint on a tube of some sort. So the activity here at the very end says, hey, don't worry about the threading. We're not going to worry about threading because Onshape doesn't do threading nicely. Fusion would, SolidWorks would, fancier, higher end, more expensive products that use your computer processing power for the most part, those guys are going to have threading as an option. When they talk about threading, there are standard thread dimensions, like standard pitches, standard threads per inch, that sort of thing. There are standards. So you can go in and say, hey, give me I don't know. Let's see what they call it here. Like a 3/8-16 UNC 3A ANSI screw thread. That means 3/8 of an inch by 16 per inch, I believe. I don't know what UNC 3A stands for. I'm sure there's a name for it. You know what? One of y'all's groups has done a research PowerPoint on this. So make sure to link that. I'll link that later. But yeah, don't worry about threading right now. Your design is going to be a neon sign where what you're going to do is use a sweep feature with a circular profile. That's a circle on the line like I did. And model a continuous tube in the form of your initials. You might need to make your initials, like if you have corners in your letters, you might need to make them rounded more and not as sharp edges. But yeah, at the end, use a revolve feature to model a tapered section between the main glass tube and a little cylinder here. So like this guy right here at the end of it as though it's being plugged in. And then you add your cylinder here as it says. So this right here, I'm going to copy this information and put it up in this description. And it is time for class to start, so I'm going to have to see y'all later. Have a good one. Bye.